Hi, welcome to sections 5.2, rectangles and area properties. So our first objective is define unions, intersections, and perimeter, and then find the area of figures. The bell ringer is what we're going to skip so you can get the notes from somebody else. Alright, for our first objective, we're going to define unions, intersections, and perimeter. So first of all, what is a union? A union is written as the union of two regions R and S, written as R union S, consists of all the points in R or S. So or is kind of the key word. So let's say I have this region right here, and that's R, and then it intersects with S. So here's S. So the union represents everything that's in R and in S. It's so basically everything. Okay? An intersection is a little bit different. The intersection of two regions R and S, written as R intersection S, consists of all the points that are only in R and S. So it's the and. So if I have my two regions, this is region R, this was region S, the intersection is what's inside. Okay? Alright, now perimeter is the distance around a polygon. So basically, you add all the sides. Alright. Okay, so now we have a couple of theorems that relate to intersections and unions. The first one is theorem 5. It says if region R is contained in region S, then area S is greater than or equal to area R. Oh, okay, let's wrap our mind around this. I have a region S, and that's the outside. And now I have a region R, which is inside of region S. So in other words, basically R, the area of R, has to be smaller than the area of S. That's all it's saying. Okay? Theorem 6, it says for any two regions R and S, then the union of R and S is equal to the area of R plus the area of S minus their intersection. Okay, here let's make a little bit of sense of this. So here I'm going to have R, and here I'm going to have S. So what's going to happen is, what we're going to do is, we're saying that the union of these two, that means everything, remember what I said with everything, is going to be equal to the area of R plus the area of S. That's true, but remember we have to subtract this intersection, and the reason we have to subtract it is because technically we're counting it twice. So if we subtract it once, then we only count it once. And so that's what theorem 6 is stating. So what we're going to do is we're going to actually use theorem 6 in a little bit. And so what we're going to do is we're going to first get some examples. So we're going to find the area of figures. So we're going to use theorem 6 in these. And basically what it's saying is if we have the area of a region, it's the area of the region union the whole. Okay, we're going to talk about that. And we're going to basically take out the whole. So we're finding the area of everything, but we're going to take out that middle. Okay, our first example is we're going to find the area of the figure. Use any method we want. So there's numerous ways of doing it. So what we're going to do is I'm going to show you 3 different ways of doing it. So I'm going to break this apart into 3 different pictures. There we go. Alright, let's talk about the first way. First way, what you could do is you could simply break it apart into 3 triangles or rectangles this way. And we know that since this distance is 8 centimeters, since it is up here, so we could say that the area of this little piece is equal to 2 times 8. this distance from here to here is 9, but we know that this is 2. We know that from here to here is 3. So that means 9 minus 3 is 6, minus 2 is 4, so this is 4. And we know that this distance is 3, so 8 minus 3 is 5. So this area is equal to 4 times 5. And then this area is equal to 3 times 8. And now we just add those together. So this would equal 24, this would equal 20, and then this would equal 16. So the area is equal to 24 plus 20 plus 16, which is equal to 60 square centimeters. Okay, that's one way you could do it. The other way you could do it is you could break it apart into 3 rectangles again. Well, you could go this way. All right, from here to here is going to be 5, because 8 minus the 3 that's right there. And so area is equal to 5 times 9, which is equal to 45. This area is 3 times 3, which is equal to 9. And this area is equal to 3 times 2, which is equal to 6. So my total area is equal to 45 plus 9 plus 6, which is equal to 60 centimeters squared. Okay. So that's when you break it apart. Now here's when you're going to use Theorem 6. You can make one big square, a rectangle I mean. And what you're doing is you're going to first take 8 times 9. So 8 times 9 is my total area. So that would be 72 centimeters squared. Then what you're going to do is you're going to find the area of the hole. So that's 3, and then this is going to be 9 minus 3 minus 2, which is 4. So you take 4 times 3, which equals area of the part. So that's equal to 12 centimeters squared. So then Theorem 6 says if I want to find this area right there, I subtract them. So 72 minus 12 is equal to 60 centimeters squared. Okay, so that's using Theorem 6. Okay, so let's look at another example. We're going to look at example 2. It says a rectangular carpet is placed on a wood floor that measures 7 meters by 8 meters. So we got this wood floor. And it's 7 by 8. And so we've got this carpet that's placed on there. And they're telling us that we have a margin of 1 meter all the way around. So that's 1, that's 1, that's 1. Alright? So in other words, we're find the area of the visible floor. So I'm going to first find the total area of the floor. So area total is equal to 8 times 7, which is equal to 56. Okay? Now I want to find the area of the carpet. So I need to find this distance first. So the distance from here to here is 8 minus 2, because you've got 1 here, you've got 1 there, so you're taking 8 minus 2 of that, so there's 6. And so this distance from here to there is going to be 7 minus 2, which is equal to 5. So my area is equal to 6 times 5. So the area of the carpet is equal to 6 times 5, which is equal to 30. So now what we're looking for is we are looking for the area of the visible floor. So that's going to be taking Theorem 6. This tells us if I take the total area minus my part, then I will get my total area I'm looking for. So it's 26 meters squared, because this is what we're looking for right there. Okay, all right, let's look at another example using Theorem 6. The area of a rectangle is 40 centimeters squared. If the length is 8 centimeters, find the perimeter. Okay, so let's draw a picture here. We've got this rectangle, and they're telling us that the area is equal to 40. We're saying that the length is 8. So we're looking for the perimeter, so we have no idea what the width is. But we do know that area equals length times width, so we can fill some stuff in. So we got 40 is equal to 8W. Divide by 8, so we got 5 is equal to W. So now all I have to do is find the perimeter. Remember, perimeter is when you add all the sides. So we got 8 plus 5 plus the top, which is 8, plus the left side, which is 5. So the perimeter is equal to 26 centimeters, not centimeters squared, because we're not multiplying. Okay, let's look at example 4. We've got the perimeter and area again. We've got the length of Joe's garden is 5 meters longer than the width. Okay, so let's just draw this picture right here. I'm just read the very first sentence. 5 meters longer than the width. So if this is the width, then the length is 5 meters longer, so it's W plus 5. If Joe uses 50 meters of fencing for the garden, what is the area? So if we're using 50 meters of fencing, this is the perimeter. Okay. There you go. Let's move that back. So then my 50 is equal to W plus 5 plus W plus the top, which is W plus 5, plus the left side, which is W. Now I just solve for W. So I've got 50 is equal to 1, 2, 3, 4. 4W plus 10. Subtract 10. And I've got 40 is equal to 4W. That means that 10 is equal to W because you divide by 4. So I'm going to put that in there. So this is 10. And 10 plus 5 is 15. So then the area is equal to 10 times 15, which is equal to 150 meters squared. And that is how we find example 4. All right, thank you.